Define the Hamilton's characteristics function and derive the Hamilton-Jacobi equation for a dynamical system. Now solution 1, Hamilton's characteristics function. Let us consider a conservative system in which h does not depends upon the time t explicitly, so that h is a constant, say alpha 1, and Hamilton-Jacobi equation for Hamilton's principal function sqpt for such a system becomes h bracket starts qj comma del s upon del qj bracket close plus del s over del t is equal to 0. Equation 1. Since the explicit dependence of s on t involves in the last term of the equation 1, so separating the variable we write s qj alpha jt is equal to w qj alpha j minus alpha 1 t, so del s upon del qj is equal to dw over del w over del qj, and del s over del t is equal to minus alpha 1. Now putting these in equation 1, we get h bracket starts qj del w over del qj bracket close is equal to alpha 1, which is independent of the time. Now w is equal to w bracket starts qj alpha j bracket close, therefore dw over dt is equal to sigma j dw del w over del qj dot plus sigma j del w over del alpha d alpha j over dt is equal to sigma j del w over del qj dot since alpha j are constant, but del w over del qj is equal to del s over del qj is equal to pj, so that dw over dt is equal to sigma j pj qj dot, because del w over del qj is equal to del s over del qj is equal to pj, or w is equal to integral of bracket starts sigma j pj qj dot bracket close dt is equal to action a. Thus the function w qj alpha j identified as a action a and is called the Hamilton's characteristics function. Now second, Hamilton-Jacobi equation for Hamilton's characteristics function. Now let us consider a canonical transformation in which the new momenta pj and all the constants of the motion alpha j and alpha 1 are, in particular is the constants of motion h. Let w q capital P be the generating function. The equation of transformation will be equal to pj is equal to del w qp over del qj, equation 2, and qj is equal to del w qp over del pj is equal to del w qj alpha j over del alpha j. The new Hamiltonian in such a transformation is given by k is equal to h plus del w over del t is equal to alpha 1 del w over del t qj alpha j is equal to alpha 1. The old and the new Hamiltonians are equal as the new coordinates qj do not occur in k, they can be considered as cyclic coordinates. Thus w, the Hamiltonian characteristics function, generates a canonical transformation in which all the new coordinates are cyclic. Using the Hamilton's equation of motion, the new coordinates are given by qj dot is equal to del k over del alpha j is equal to del alpha 1 upon del alpha j is equal to 1 if j is equal to 1 and equals to 0 if j does not equal to 1. So q1 dot is equal to 1, which implies q1 is equal to t plus beta 1 is equal to del w over del alpha 1, and for j does not equal to 1 qj is equal to 0, which gives qj is equal to beta j is equal to del w over del alpha j. Therefore, out of all the new coordinates qj, only q1 involves the time and thus do not a constant of motion. It is not necessary always to take alpha 1 and the constant of integration of alpha j in w as the new coordinates of momenta.